Awesome. Hello. I'm Jan Čelák. I'm also on the program committee, and welcome to the next session. In this session, well, before we start, I should remind you, if you have any topics for the lightning talks, please submit them during this session, because by the end of the session, we will meet together with the program committee and select the talks. In the session, we will have, or the common theme will be Encrypted DNS. And we'll have 3 talks, and the first one is by Dr. Paul Vixie from Farsight Security, and he will talk about some of the challenges of deploying or dealing with encrypted DNS in private managed networks. So please, Paul.
Hello, everyone. I haven't gotten around to shaking everybody's hand yet, but you're on my list. So we have all, I think, been touched in various ways by changes to DNS that have come out of the web community. And so we call it DOH, but turns out DOQ is also coming, and there are various implications. I'm not here to comment on the technical merits or potential challenges of doing this. Rather, I want to explain to those of you who don't operate networks what are some of the pressures coming to people who do operate networks from this protocol. And we're going to be differentiating about what kind of networks you operate, right? Theoretically, every host is a network and has a loopback interface that only it can talk to. And that is kind of what I mean. That is a managed private network. Nobody can tell you that your personal machine has to accept some traffic or has to generate some traffic or has to always send something to some place. And so your laptop would be an example of a managed private network. A lot of us do the same thing with our family networks, with parental controls sometimes implemented as DNS filtering. And again, this is not something that we're expecting a regulator somewhere to tell a family, you can't do that, you have to not filter things. I realize that there are some regulators in the world who tell their families that they must filter certain things, or that their ISP must do so. But in general, these are sort of not public networks. They're not subject to regulation. Not really subject to law, although if you break the law using a managed private network, you won't find that that is your shield against prosecution. And I think a lot of confusion occurs when you think about the web as this fully connected thing where everybody wants to be able to reach everybody, and there's constant obstacles, and you're constantly having to tunnel this over that in order to get your work done because you're in a hotel that didn't think anybody would ever want to do the thing that you want to do. So we've got a lot of pressure, both regulatory and technology pressure, to try to sort of force public networks, and that sometimes includes coffee shops or hotels, but almost always includes access networks. You know, if you're selling fiber to the home, if you're selling DSL, you're selling Wi-Fi to somebody, then there may be either a trade policy or a telecom policy that then affects you as a seller of those services. And at that point, you can begin to face mandates from superior forces like your own government that require that you either do or do not filter various things. And it is that latter type of network that a lot of the DNS encryption efforts are targeted toward, because those networks have, in the opinion of many people, sort of abused their position on path. They are sort of taking prerogatives that are more normally associated with those of us who have a managed private network. So what I'm hoping as a result of all this today is to get us onto a similar enough page that we are all aware that there are 2 fundamentally different types of network if you can just recognize that some types of networks should be regulated and some types should not. And it is not so much of an us versus them, it's a, gee, the internet has prospered because we have let people work the way they want to at the edge for the most part. So you could even think of this as some of the old edge versus core, where you'd say, I want my core to just pass the packets, please. Don't create a lot of state. Don't make it impossible for me to pass new types of stuff. I can tell you that as a result of a bug in Cisco IOS that was sometime in the mid-90s, before ISC had 950 charter, because I remember where I was sitting when we had this problem, it is still broadly impossible to get wide area UDP to work for the SNMP port, and that's because of a Cisco bug that was fixed more than 20 years ago. And we would all like to not have that problem lingering in the core of the internet or in any of these public networks. We'd like them to, by and large, stay out of the way and let us do what we want to do, especially if it's a new thing. So there are, I don't want to say good people on both sides. I want to say that there are many sides, and it's only when we all recognize the sidedness of this, the multi-sidedness of this, that the internet continues to be a vehicle for the innovation that we're used to. So what we have here is my cartoonish attempt to indicate that there are a number of gates that signals, which on the internet are packets, have to pass through to get from some user somewhere to some service somewhere. And, you know, I can wish that we had a little bit more peer-to-peer traffic than we do, and it wasn't moving in such a terrifically client-server model, but that really is a topic for the bar tonight. So what I'd rather say is that historically, it has been possible for the owner of each of these gates to withdraw their cooperation. If they move their gate out of alignment because they don't like that particular kind of traffic, then that particular transaction would simply fail. And yes, that has been, I think, significantly used by autocratic states if they don't want you to do something that might, you know, be to criticize the government, and you know, they have to be able to see what you're doing, so they're not going to let you do a certain type of crypto. Then a lot of people from non-autocratic backgrounds look at that and say, that's a hell of a way to live, I don't want to do that. But if you take that example out and say simply, maybe it's your CISO with the corporate firewall and the corporate policy, maybe it's the head of household for a family who maybe wants parental controls implemented in DNS. I know British Telecom offers that as a service, as I think does Comcast. Then we really don't want, let's say, the children in such a household to have a really easy way to bypass the filters that the head of household has decided should be there. And so we've traditionally said that if you operate one of these things, if you are one of these things and you don't like some things, then you can just say that's not happening. I started the first distributed reputation project with MAPS, the Mail Abuse Prevention System, and with Eric Zegast's help, we created the first RBL, which was a way to express policy in the DNS about mail servers, or reputation information about mail senders. And a lot of people came out of the woodwork and said, Paul, you can't be picking and choosing what email you accept. If you're going to speak the protocol, then you have to accept all the mail. It's like, no. I own that mail server. I own the hard drives. I own the hard drive where my inbox lives. If I don't want somebody to scribble in there, then, you know, possession is 9/10 of the law. And so we had a lot of arguments about whether the internet was viral and an all or nothing proposition, or whether it was just a big thing that you had to sort of watch your step and conform to certain norms lest you be excluded. And those arguments were happening at the same time as commercialization and privatization. And by and large, my way of thinking about this at that time became compatible with what came later. And that's mostly because if you get away from radical idealists like myself and talk to corporate management and their investors and corporate counsel and so forth, then it becomes obvious, yes, if the company is going to be responsible for everything that comes out of this network, then we're going to have a firewall so that we can enforce policy so that that responsibility will be bounded by some controls. And so most of these managed private networks have firewalls of some kind, and they operate at many layers, not just IP firewalls. We've got web firewalls now. We've got, of course, DNS firewalls with RPZ and with other technologies. So I'm trying to set the stage for how things have been, because they're in the process of changing, which is the user-centric networking model means that you can talk to the service of your choice and nothing can stop you, because nothing can see what you're doing in order to express some differentiated policy and say, well, this I allow and that I don't. If this can mean, for example, that if you have ad blocking implemented in your client operating system, then that's not going to work, because your client operating system is no longer going to be consulted about lookups, and is no longer going to be able to see, because of encryption, any of the data that the app is exchanging. And this is not the end of the world. Certainly ad blocking can also be done inside web browsers or plugins that web browser might adopt. But this should tell us that there's a broad range of things that things in the middle would have liked to be able to make a decision about for reasons other than autocratic, oppressive governance of an unwilling population, or perhaps overreach from a national security actor. So what you're seeing here is kind of a replay of something that's been done in a lot of other areas, which is, look, don't add value, don't subtract value, just be a dumb pipe. I know what I want to do. But it is a very extreme form of that. So here's another example of how things have traditionally worked in these managed private networks. For example, the virtual hypervisor in my laptop has a whole bunch of little virtual clients where I do all of my work, and the hypervisor has got a firewall that forbids certain outreach unless it meets certain criteria, therefore forcing, among other things, that all of the apps running on all of my VMs have to use my recursive name server, and there's a lot of things I won't resolve. I am both the co-inventor of response policy zones, which was a DNS firewall, and a heavy user of it. And there are all kinds of things that I don't want any app running on my laptop to be able to look up. And they can't, because right now, unless you are my recursive server, you're not going to be speaking the DNS protocol to get out of the managed private network that I operate in my hypervisor. And we have a similar topology at my day job. We have a similar policy for my family's home. And this goes along with the idea that anybody who has one of those gates I showed you in the first slide can slide it up or down to take themselves out of alignment and keep certain types of transactions from getting through. But that was the internet era. Now let me show you the web era, which is where we had this apps doing DNS thing. And they speak a protocol that is indistinguishable from other normal web activity, which is normally commerce or looking at pictures of cats. And this bypasses all of the machinery that has been carefully put in place. So this is the web era. And if you were born in the web era, then you think that this is normal, and you think that this is how everything should be, and that anybody who's still running a firewall needs to get themselves out of the 90s and start thinking thoughts about the Beyond Corp model and so on. And so that is the new battleground where we will discuss who gets to decide what protocols my network is going to speak and how I'm going to secure it. But I have to tell you that there are malicious apps, there are malicious users. Some of the malicious users are insiders, some are intruders. And the way that I find out if I have a problem is by looking at my firewall logs and seeing what alerts it is raising. And I am one of tens of millions of enterprises around the world who depend on being able to see and stop DNS in order to secure their network. And simply telling them those days are over will both be controversial and unsuccessful. They will find something else to do besides turn this off. So, we have these prerogatives because we own everything on our networks. We're not doing commerce with members of our family. They're not paying money. They may be paying in household chores, but they're not paying in money to get the Wi-Fi password. So no law, no regulation, nothing tells us how we have to treat the traffic on our own networks, and that's also true for corporate networks. And so these managed private networks, they offer certain prerogatives that would be inappropriate at broader scale. Nevertheless, if you're on path, as a public ISP network would be, or a state-level actor, or an ISP who is under maybe unpopular governance from an autocratic government, you have the same powers. And in my opinion, you are then usurping the prerogatives of a managed private network operator. But it turns out that not everybody comes to me to find out what they should and should not do. So it's pretty popular to then usurp the prerogatives and start behaving as though it is your right to decide what goes and does not go across an otherwise public network. This cannot stand. It will not stand. This was not a tenable equilibrium. So what happens is what always happens on the internet. If you behave unilaterally, then you encourage others to do likewise. So that's where we got VPNs in general. That's where Tor came from. That's where PGP came from. It's a bunch of people saying, wait, that's my prerogative. I am going to unilaterally force you through the use of technology to stop usurping it. But this is also where DNS over HTTP comes from, and TLS 1.3 and the ability to encrypt SNIs. Right? If you visit China and you try to get from China to the outside world, other than on your cell phone where you have some kind of VPN tunnel back to your carrier at home, if you actually sit in your hotel Wi-Fi and try to reach a lot of places in the world, you're going to discover there's a man-in-the-middle thing on the HTTPS protocol that is offering you kind of not the certificate you were expecting. And the deal is, if you want to get out, you've got to believe that certificate, which means you're going to let the operators of the Great Firewall of China see everything you do and possibly break some of it. So that model is not just used in China. We're seeing it around the world, and we're seeing it on ISPs. We're seeing a lot of inappropriate monetization and keyword scanning and ad insertion and all sorts of things happening because there was power available to on-path actors, and they took it. So now we are, as a community, building things that will then break all of that and make it necessary that those actors either become dumb pipes or they behave more cooperatively. So this was inevitable, and I'm not happy to be caught up in it all. I'd like to have a more peaceful world where I can get some things done without having to think about this stuff. But I don't see this as a unexpected development. The disclosures Edward Snowden made in 2013 before he flew to, or I guess after he flew to Hong Kong, had this predictable outcome. There is always, action and reaction. And there won't be an evil bit. Steve Crocker wrote an April 1st RFC once where he described a bit in the protocol called the evil bit, so that you could just tell everybody along the path, by the way, I'm doing evil, you can stop it by looking at this bit. That's never going to happen. That's why it was an April 1st RFC. So the things that I need to do to protect my laptop, my family, my company, and defend the networks of those parties are indistinguishable on the wire from the things that actors I consider bad, like autocrats who insist that the network be exposed to the government, they look the same. We're not going to be able to develop some protocol that gives me permission to do what I do that is not abusable by these other actors. So that's the going in position. Now let me tell you what we've got to do about it. We're going to be firewalling off any protocol if we can't tell when a transaction is being initiated. And in some cases, this will happen anyway because the NAT box will just not be able to set up state, and you won't be able to do end-to-end stuff with the address translation unless you pass whatever the policy is. So with Quick, for example, it is going to be possible to look at the unshrouded portion of the UDP datagram to find out if this is an initiation packet. But then the address mobility changes are shrouded. So if the far end needs to move to a different address, the endpoints will know, but you as the middle will not. So it's possible that Quick is never going to work inside of managed private networks, and that those networks will just block it all and deal with HTTPS over the TCP that we've had all these years. We're going to have to find any outside HTTPS service which is known to support DOH. And that is a fool's errand, but it is one we will have to pursue. And we're going to force the use of an explicit proxy rather than doing this man-in-the-middle thing. And that means we won't have any IoT devices on those networks because there's no way to set their proxy variables. That's not something that DHCP or any other discovery protocol uses. I have to use a PIN number to get onto some Bluetooth connections or some Wi-Fi connections. We don't have anything like that for proxy discovery, so that my refrigerator, for example, just expects a clear path. Okay, it's not going to get it, so that part's just not going to work. So we'll be living without IoT on those networks. And this BYOD thing where people are bringing their own smart devices to work and putting them on the corporate Wi-Fi, and that is such a hard problem that the IT department has been looking the other way. They're going to have to come to terms with it. Now, the public networks simply can't do any of that. This is untenable. And so that means that the main purpose of DOH will be served. The managed private network operators were never the target of DOH. We are collateral damage. Right. So I want to get to questions, but I also want to sort of prep you for the inevitability I see coming next, which is that the nation-state actors who want to see what we're doing and are concerned about the economy going dark are, generally speaking, not evil people, right? No one is a villain in their own eyes, but these people are not even villains in your eyes. They are just patriots trying to comply with the government's policy for the most part. And if we say, okay, we got to make you go dark because you misbehaved, they're not going to say, okay, that's fine. They're going to do the one thing that's left to them, which is to get even deeper into our supply chains at the endpoints, because that's the only place this traffic will be in clear text. So just as action like misbehavior as or overreach, in my opinion, as exposed by Edward Snowden, had the reaction of all this crypto, the action of all this crypto is going to provoke a reaction. This is what I think it will be. Remember that this is a game. This is, there's never a last turn in this game. Every time one side makes a move, then the other side considers that and decides what move they will make. So anything that you thought you were going to do where you thought that was going to be the last move in some game was, in my opinion, naive. So we have a few minutes for questions.
Thank you, Paul. Does anyone have questions for Paul or comments? Please don't forget to introduce yourself and state your affiliation.
I'm going to be brave. Tom from Cloudflare. So you talk about using DNS as a way to effectively filter traffic. And you mentioned that potentially in the future you will need to use service IPs to do that. In your experience, why can't you use service IPs to block it from the beginning?
Why? Say that last part again.
In your experience, why do you need to use DNS to do the filtering of traffic? Why can't you just use the IPs that they're connected to filter traffic, which you could still do with DOH?
All right, I do not want you to take this personally, but I'm going to use Cloudflare as an example.
Please do.
According to a report published in the EC last year, Cloudflare is responsible for either 30 or 60% of all intellectual property theft in the world. And sometimes it's either 30 or 60, depending on who you ask. Either way, it's a lot. And there's only a couple of IP addresses, and all the content, both that which infringes and that which does not, is going to have the same IP address. And you know, if you would use the evil bit and simply say, we're going to put all of our intellectual piracy stuff on one IP address, you can block that. That'd be cool, but I know you're not going to do that. So what we do is to differentiate, to identify which of your customers we don't want to be able to talk to. We look at the DNS lookup, and we block that by the query name. So I really am not intending to pick on Cloudflare here. There are 10,000 other companies who have the same setup you do, and that's why we had to develop the RPZ. That's why some people run their own recursive name servers, is so that they can be able to block this stuff for all of their endpoints, for all of their apps, without having to go app by app, endpoint by endpoint, and hope the maker of a certain app even provides the kind of filtering we want. We've just been doing it with DNS. And the second part of the answer is, look, we've all got malware, and if we don't now, we did, and we will soon again. And often the way that we first discovered, I don't say we, I don't mean Farsight, I mean the entire enterprise security industry, which is, what are we thinking here, something $20 billion a year in annual revenue goes to services that have to do with behavioral detection, because on a network you never know where the next bad thing is going to get in. And if you are, forget about filtering to remove the piracy, but just look at the detection. If you're watching these queries, then you know, look, that thing must be infected with a certain botnet, because only that botnet makes that query. So we're using this for behavioral security, and we're using this for policy enforcement. And we can't just say we're not going to do any of those things anymore.
Do you think that's an effect of centralizing of service hosting platforms like Amazon and other things, or of encrypting DNS and SNI?
So when we deploy in AWS, we point all of our hosts, our virtuals, at a recursive name server that we also host inside of AWS, because we cannot trust AWS to filter based on our policies. And so even in those cases, we're going to have to make sure that there is something in every one of our VPSs that prevents DNS from being delivered by any means other than through our filtering resolver. So I don't think this is centralization. It's the opposite. This is saying the edge has been autonomous in this way. We're not going to leave it up to app vendors or teenagers what DNS they're going to use, or intruders, or malware, or poison supply chain. They're going to use our DNS, period, full stop. I'm not in a position to negotiate about this. Brian.
Brian Dixon, GoDaddy. Another observation is that there are data over DNS exfiltration and infiltration methodologies that are out there in the wild. And if you do not have the ability to monitor or block that DNS traffic, you are exposed to that exfiltration. The client recursive is just doing a query, but that query would include encoded, encrypted data that gets delivered to the authority for that zone. The only way to even see that is to monitor the DNS and look for high entropy. Yeah.
So this has to be the last question because we're under time pressure. And my answer has to be short, which is that the first time that somebody showed me a VPN that was delivered over DNS, where the query was one direction and the answer was the other direction, you could have knocked me over with a feather. Because the demo they used to show me that this could be done was Skype. This worked at multi-gigabit or multi-megabit speeds. So as bad as it sounds and as slow as you think it's going to be, it works. And this is an example of something that people do either by looking for high entropy in their response flows, or maybe looking at the rate profile, or what I do is I just subscribe to an RPZ that knows most of the DNS VPN endpoints as DNS apexes, which is that all the queue names that are the forward direction are going to be under a certain apex in order that those questions get delivered to the servers that understand this is a VPN. So there are lists of those, and you can subscribe to that and just tell your recursive name server, if you get a question that's under any of those apexes, then say no. And again, we're not going to stop doing that. Managed private networks are not going away. The Beyond Corp model is probably 50 years away from entering the average person's home or business. Thank you all, and I look forward to discussions at the break, and I'll be here all night at the social.
Thank you, Paul. So the next presenter is Ralf from Akamai, and he will share some thoughts and insights with encrypted DNS from the operational perspective, please.
Hi, everyone. My name is Dokter. I'm a product manager with Akamai. I'm joined today by Ralf, who I'm sure everyone knows. He's our principal architect. And we have Bruce hiding in the background there, who was instrumental in trying to keep us professional with all the various things that we put in there. One of the things that we want to chat around today was some of the operational experience and the insights that we've managed to gain over the last 6 to 8 months as we've helped customers both trial and plan for their production deployments of DOT and DOH on their resolution infrastructure. There are several questions that we see from customers around what is involved with deployment of DOT and DOH. In the interest of time, because we have probably entirely too many slides on this, we tried to focus in on the one question. We exposed some of the observations that we had around this, and then once I've gone through that, I'm going to hand over to Ralf so he can do all the fun stuff around the analysis and the testing that we had done based on these observations. So one of those fundamental questions, and I think one that is quite important to operators today in terms of how they plan their rollouts of DOT and DOH is, what does DOH mean for our DNS infrastructure? How do we capacity model for this? How do we capacity plan? What is going to happen when clients start switching from normal UDP DNS to some form of TCP-based DNS? And in many of those cases, the answer that I'm able to give is not necessarily the answer that they want to hear, in that it's very much dependent on what the clients are doing. So in order to try and drill into some of the clients that are readily available today, we grabbed a bunch of sample data sources from those clients listed there. Firefox was obviously one of the clients, and we had several clients running this, both within some of the residential environments that we were talking about, as well as roaming locations, airplanes, backup Ubers, that kind of stuff. There was also a collection of residential CPEs that we set up and started gathering data for. There was a pfSense installation with about 35 devices in the household. I was a little bit surprised by how many devices there were, but once you kind of count all the kids' devices, the laptops and Xboxes and everything, it worked out to quite a few. There was also another installation with Stubby, and there was about 15 devices behind that, and then we had a AVM Fritz box with about 10 devices behind that. So some of the high-level observations, and I'll try and step through this quickly because, as I said, we probably have too many slides. The user experience when it came to configuring Firefox as one of these clients was pretty well known. It's fairly simple. All we had to do in this case was navigate through to the preferences, specify a custom provider, and point it to our test DOH endpoints. One of the key observations that we noted around this, which was good news, is that there was some pretty good session reuse. So across the total queries that we saw, the 268,000 give or take queries made through those 62,000 connections, we noticed about a 4.32 queries per second across each of those unique connections. So that session reuse is pretty important, and we'll get into some of the details in later slides. Other observations that we had there was that it was just generally well behaved. Even when we had a bit of a sysadmin hiccup, my fault for not paying attention to cert expiry, we didn't notice any interruption in our browsing experience. Now, that sounds like a good thing, but it kind of caught us by surprise. We know that the failover mode is to fail open as per default, but at the same time, I hadn't realized that over the 4 or 5 days that the cert was expired, that my experience was not as secure as I would have assumed it to be. So I think at some point, we're going to need to expose whether or not a customer's interaction with their client is secure or is not secure, and understand more about how these failure modes work and how to signal if you're secure or not. The second CPE client, this one was fairly interesting. The user experience was also pretty standard. The user front end exposed clear ways for us to configure the TLS to forward to upstream servers across DOT. One of the first things that we noticed is that there was no session reuse at all with the CPE. Because we weren't able to calculate the average queries per second across the sessions, what we did is pulled out some of the packet captures that we had on the server side and identified that most of these conversations that we had seen had a lifetime of between 0.29 seconds and 1.22 seconds. Probably a larger observation is that we also figured out that we were losing 2% of all queries that were sent to the CPE. So about 70,000 of the 3.4 million queries that we had sent through this over the month and a bit that we're using it timed out. And these queries are not seen at the upstream resolver at all. So something happened between and those queries were lost. That said, these timeouts represented a mostly unnoticeable user impact, and I say mostly because the users in my household did not complain that I was breaking the internet, and it was only really me that kind of noticed things when my Firefox happened to break, and I have another slide around that we can get into those details. And it really manifested itself as just not being able to browse through things, and you refresh and it comes back. So there were certain triggers that caused me to investigate a little bit more, but it was mostly unnoticeable. So there is something to be said for default retries, obscuring some temporary errors there. We did try and do some basic troubleshooting. We kept it within the realm of what a standard user, not necessarily a power user, would be doing in these cases. We also did try and eliminate whether it was the upstream resolver that we're using. We tried to use multiple resolvers, both private and public cloud. We also tried to upgrade to the latest version of the resolver that was in the pfSense repo. There were additional things that we could have done. We realized we probably could have put Stubby in as a TLS forwarder that was able to do session reuse, but that was outside the scope of, I think, what the normal user experience would have been. The other thing that was noteworthy is that we typically noticed that there was a lot of TCP states left in time wait, usually between 30 and 120, depending on how busy things were. The third residential CPE was a Stubby installation, also pretty good reuse of the sessions, so 3.61 on average. Observations here were no issues. It didn't hiccup, there was no problems, it was just a non-issue, which is kind of what you want from this kind of experience. That said, we do realize it's not necessarily representative of the average user. We try to find things that have some kind of UI to configure things, but those are still fairly immature these days, so we added this as an additional data point. We also realized that out the box, Stubby has a stricter default configuration. So had we had a situation where that TLS authentication parameter specifying as required there, had the cert on the upstream forwarder expired, this would have been a fail-closed scenario, and it would have been pretty difficult to troubleshoot. So something to bear in mind as you figure out kind of the default failover modes to go through. The fourth client, also a very good user experience. ABM Fritzbox, I think it was running a dev version released in December, if I understand correctly. Also good session reuse, the best we had actually seen out of all of them. Again, no issues. And in this one, the fallback behavior was very clearly defined in the user interface. So it was nicely exposed and I think fairly clear for anyone who was looking to enable DOT. So based on the cert validation failure and understanding all the corresponding client behaviors, we put together this basic table of figuring out, well, if you're running DOT and DOH services on your resolver, you now also need to pay attention to what the clients who are using these services will do if there is a failure scenario. So we've got a collection of clients that we were testing throughout the month plus, and the failure modes that are by default out the box. The only two data points that I think I want to call out there is we still don't fully understand why the pfSense box failed closed when TLS failed to negotiate when that cert expiry happened. The fix was somewhat disappointingly a kind of a Control-Alt-Delete of the CP, and then it just started working. So we need to re-engineer that failure and figure out what the exact cause was. But at the same time, we do know that the resolver in use there is planned on their roadmap to add session reuse support. So I think the only other variable was the Fritz box. By default, we expect that people will probably set it to fail open, but if they don't, then obviously it'll change that default to fail closed. The other observation that we tried to figure out, and this was mostly based on us trying to figure out what the optimal values were for us on our server side from an idle timeout perspective, was what other providers were doing. And as you can see, the values that we're seeing from timeout specified across other providers are across the board. So it's going to be interesting to see how this matures. I'm not too sure why some are quite high and others are very low there. It would be interesting to understand if that low idle timeout for Cloudflare has a reason, and then kind of understand the rest of those values there.
Okay, I digged a bit deeper in the data. As you might know, the servers that we run can store all the queries in a log, or it's a bit more complicated. But it is that given that we are based on UDP, it's kind of like a query log. So we have every information over the query, but we don't have anything about connection. So I needed to actually kind of find out what the connection distribution is by looking at the query log, seeing if the client port and client IP was the same, and if the kind of time difference was above 10 seconds, then I know that because our client timer that we decided on was 10 seconds, then it would be two different connections. So I did a bit of a Python script to actually get the connections and the queries out of that, and then I graphed it a bit, and that gives you a bit more information. But the graphs are log scales, and one of the things I noted just, after the graphs were done is that in the query store that we have, the last packet is really starts the idle timer. So that means the connection still stays alive 10 seconds after that until the idle timer kicks in, because we didn't find with a 10-second idle timer that any client that we tried really dropped the connection. I'm not sure what the timers of the clients are, if they have one, but for 10 seconds, we just didn't have any client that dropped it. So that is the connection time distribution. The numbers show you the percentage of connections that we have in that time frame. So as you see, most of the connections are 10 seconds, which actually means 20 seconds because of the idle timer. I mean, you usually see 95% or even more in that case. The interesting thing that I also found is that you see the difference. I called it Canada DOE because it was his Firefox, and Germany DOE, which was my Firefox. I believe the reason that there is a big difference is that my Firefox uses NoScript, uBlock Origin, and Privacy Badger to kind of try to really get rid of all that kind of cookies that people send around there somewhere. So, and on the JavaScript that people are using. So it usually times out quite faster than, because a lot of the websites that you get today, they have also these endless things that run and do stuff. So it looks like there is a difference there if you install these things in the behavior. But overall, we see pretty much most of the stuff happens in short connections between 10 and 20 seconds. And the query distribution, again, it's pretty uniform. We said, 3 to 5 queries per second average, and it kind of decreases with the connection length, so to speak. So there's nothing surprising there. Now, with all that information, I now want to actually test some stuff, because we often get asked by customers, well, how do we size this stuff for the new DOH, DOT world? What are the differences? And DNS over 53 or regular DNS is pretty simple. It's about throughput. You get queries, you don't care from what client, you just answer it. It's a single kind of query in, query out, and you're done with it. And in most networks, what we have on fixed networks is we have 0.25 QPS per subscriber, mobile 0.15. That's rough by thumbs number. So if you know we have 2 million subscribers, you can easily kind of figure out the QPS you receive. Now with TCP or dot or DO, that's different, because you introduce that connection element that just wasn't there for regular DNS. You just don't care. And you need to take about the connection lifetime, how many queries there are per connection. And the other thing that goes more for DOT and DOH is you're introducing an encryption, CPU-intensive encryption there. So you'll have to see what is the CPU load on that if you kind of initiate the connection, because that's usually heavier, and when you run a steady-state encryption, so you just have done the connection setup and just encrypt stuff. So there are some assumptions I have to make for the lab test, and I'll show you that in a later slide. So here's a test setup that I had. It's real hardware I used a couple of years back for some performance testing. It's a pretty decent box, 64 gigs of memory, which was not enough, 40 cores and a 10 gig Intel NIC, because for UDP, don't use Broadcom, just don't use Intel. And to do the UDP testing, it's similar. You have a similar machine. I didn't push it to the limit, but I just want to see if the performance was there to do some small UDP testing. Now, for TCP testing, I needed much more machines, and I want to thank our Q&A guys for, on short notice, giving me some machines that I could try to test for. Again, the tool size. The tool set that we have for UDP DNS testing is, OARC has it now. It was developed originally by Nominum. DNS-Perf, it's fine, it runs good. Now, DNS-Perf also supports TCP and TLS, but it does that for a setup that I don't see, very realistic. And I really want to find out how many clients we can support on these boxes with DOH and DOT, or how many connections, because that will be an important number going forward to size this stuff. So I wrote something myself using Python 3. Now, just go back to DNS over 53. That's really, it's easy. It works. There are the first two settings are buffer size that you need to increase. They're a bit low per default on CentOS. I think they are a third of it, if I recall correctly. So if you set this buffer size, and the last one really, you only need to set for DNS testing, because in a production setup where you have tons of IPs coming to your network, you don't need that. But for, it's the hashing, I think, someone brought that up earlier, the hashing that you have to do over the ports rather than the IP addresses. So that's really the same thing you have to do. And then you start DNS-Perf, and this is a single instance of DNS-Perf. It goes up to 600,000 QPS, no problem. So it just works. That's how you do DNS testing on UDP53. So DNS over HTTP, again, I needed to do some assumptions. So the 0.25 number actually was good, because when you think about the number we had in the queries per connection was between 3 and 5, and the connection length was 20 seconds. That means, 4 queries every, or 1 query every 4 seconds, which is 0.25. So I think the number is still good. So the script I had pretty much does a query every 4 seconds that kind of catches the 10-second timeout timer, so the connections stay open. And then I used Python, I mean multi-threaded module. I used the stock Python out of CentOS because I didn't want to install or compile stuff on the 12 machines I borrowed from QA. So I'll just use the stock. I think it's Python 2.7 in CentOS 7 now, I believe. But anyway, the standard Python. And I then try to see how many threads I actually could get out of one Python script, because Python also has limitations, and it turned out to be around 1,000 that you can reliably do with that method. And then you'll add more instances. I mean, it's Unix. You can start multiple processes, not a problem. So to go higher. So I wanted to go to 5 or 6 digit numbers. So I started a couple of processes, didn't work. It kind of, the Python code crashed all over me. So what's going on there? Well, it's connections, because remember, for a connection that is kind of stays there, you need a source port. And source port, there are not that much available. The default configuration for CentOS, I think, is 30,000 source ports. And you really can't get over 16-bit or 60-bit minus 1024. So you'll need more machines to really push that. And that's where QA came to the rescue. I could reliably do 50,000 connections from one machine, and then I needed another machine. So, okay, no problem. I got more machines. And the thing that I couldn't push, though, was the file handle stuff over 1 million. But I didn't need it, so that. And if you ever do security limits, I'll show you the next slide. So the detailed tuning that you have to do, you have to add the ephemeral port range on the clients so that they can open more than 30,000 connections. And on the server, you have to pretty much tell them, reuse your ports faster and reuse them. And allow the system to open many files. Now, the syscontrol fx files 4 million there. You can set that even higher. But there's etcsecuritylimits.conf, and again, someone with more TCP kernel knowledge can help me out there, hopefully. That was the maximum number I could push. It's 1024 by 1024. And again, if you change that, and you do a sudo vi etcsecuritylimits.conf, and the number is one higher, and you exit out of it, the machine is doomed. You cannot do anything any longer. You cannot log in. You cannot even on your shell that you just did that command on run anything. It just stops working. You need to get someone to put it in a single user and then change the setting again. So yeah, ask me how I know. So with that now, let's try to kind of see if we can crash or if we can kind of push the machine to the limits and see how far it goes. Stuff I want to know: how fast can I create new connections? How many active connections can we serve? And what will be a CPU load, and when will it break? Well, here's how it happened. So the first initial ramp up is, and again, this is the gist of a couple of days of testing. I could get the machine up to, say, create 7,000 to 8,000 new DOH connections per second. If I created more than that, the Python that created the connection failed. So that was I stepped it out a bit, and that was 7,000 to 8,000. And you see the CPU numbers, your CPU percentages are on the right. Peaks at around 2,400%. And that's because we have a limit. We might want to think on raising that per thread group, and this runs all in the TCP thread group. We only can assign 24 threads. So we don't want to assign too much threads so that we don't kill it. Okay, trying to speed up. And that you see that ramp up is quickly, and then we'll go up to I believe something like 80,000 queries per second. Now, I couldn't actually graph the connections because there was nothing in that output format that I tried to graph this that had that on. So I would graph QPS, but if you think about, I'm asking one query every 4 seconds, so if you kind of do that times 4, you'll get the connection number. And that worked fine up to a certain limit until it kind of, I couldn't increase the connection because the steady state on answering also kind of required some CPU cycles. And then I went more slowly with creating the connections, and you see, I think all of this, I believe, are 10,000 increments, if I might be more, I can't recall exactly, but you see the increments that I'm doing, and it gets more and more and more connection, and the server answers more queries. And the steady state is below 1,000%. That means it used less than 10 cores, which is good. And then when that spike comes, that's when the server started to probably try to figure out, where's my memory? And can I maybe squeeze in a bit more of memory? And then when it drops further, that's when it's sort of, sorry, I'm running out of memory, I have to swap. And that was really a problem. The maximum amount of connections I could get out of a 64 gig machine was 460,000. And then the machine started swapping. The server didn't crash, so it did recover, but the connection, of course, were dropped. And at one point, the connection that I couldn't create more correction, they were dropped. But overall, it scaled well. So I did a second test that I have no graph of, where I pushed an additional 100K QPS over UDP. Not a problem at all. So the 460,000 were doing 120 something K QPS, and then I could push an additional 100K with no problem. So the UDP doesn't require more, but I think overall it's quite successful that you can actually run servers with lots of TLS connections. And with that are the closing thoughts. I mean, DNS, I mean, the clients that we used were mostly okay. And we need to tune the servers differently for TCP than we need for UDP, but we can do it. And the server-side multi-threading is really important, and it worked really well. I was a bit surprised by that. So it means that if you have lots of cores to give to your server, you can put UDP and TLS and DOH at it, and it scales really well because it uses sort of the different cores. So you might, our old saying was, well, use less cores and more faster cores, but with the new loads that are distributed between DOH, TLS, and UDP, you actually might go in a different route. Any closing thoughts, Mark? Memory. Yeah, memory. Lots of memory. Yeah. Okay. Questions?
Thank you, Mark. Thank you, Ralf. Do you have any questions?
Hi there, Brian Summers from Cisco. I just checked one of our resolver configurations, which is running in latest Debian 9 kernel. We configure the number of open files to 26 million on there. So
in security limits?
So this is just sysctl fs.filemax.
Yeah, as a file max, you can configure way bigger. But the problem is the stuff that the process uses when it starts up is from etcsecuritylimits.conf. Okay. And that I couldn't get higher.
Interesting.
We still have time for a few more questions, if there are any. If not, then thank you again. And our last speaker is Rescorla from Mozilla. I would especially like to thank him for coming to DNS-OARC because we don't have many representatives of browser vendors. And Eric will talk about state of encrypted DNS in Firefox. So please.
Howdy. So this is somewhere between, it's not really a technical talk. There's some technical parts, but mostly this is a briefing. So if there's something that's not clear, by all means, jump in, ask me a question then, unless the organizers say you can't. But yeah, I'm happy to clarify things as much as I can. So hopefully it should be clear. So people often ask, why are we doing anything at all here? So Mozilla has this manifesto that actually is an attempt to guide the work we do. And so it has these 10 principles. I think they added a few more recently. But principle number 4 says that individual security and privacy on the internet are fundamental and must not be treated as optional. So we take that really seriously. We take it as a commandment to do the best we can to protect user security and privacy. And we think that's an obligation the browser has. That's the motivation for any of this work. I will not drag you through this diagram. I've used this diagram other places and tried to explain what a recursive authoritative is. Obviously, I won't drag you through that. The key point here is that red circle is the thing we care about, namely the connection between the stub and the recursive. We care about other things too, but we're not going to try to do much about that. We're just trying to fix this particular piece. This architecture at a high level has 2 main security problems. First, how do I pick which resolver I'm talking to? As people generally know, when you join your average network, you just get the resolver of the network. So how do I know it's not an attacker? And once I've selected that resolver, how do I connect with securely so that attackers can't see the request and response I'm making and thereby determine what I'm doing, and also so they can't inject false responses so I go to the wrong place. And so secure resolution, and by secure, I mean the typical definition of integrity, confidentiality, the full panoply of security measures requires addressing both of these issues, not just one. So first question, obviously, and we think of it in that order. So where do you get your recursive resolver? In most people, most consumers, hence most Firefox users, get it from the local network. That typically means your consumer ISP, or an enterprise network, or the coffee shop network you just joined. There was a big sign there that said Nanog, and I just pulled down Nanog, but I have no idea if that's actually Nanog. It's just some name I was given. Anybody can make that access point. This is totally opaque to the user. Users, by and large, don't even know what DNS is. They certainly have no idea where the resolver comes from. They have no idea what the policies are. I actually urge you, if you have a residential ISP connection, to go and try to figure out what the policies of your ISP are with respect to your DNS traffic. It's not obvious. Depending on who you have, some are better than others. And often they'll say things like, well, we share your data with other business partners for various needs that we think are appropriate. Some users do, of course, choose their own resolvers. There are a number of popular public resolvers, such as Google Public DNS, Cloudflare, Quad9, Umbrella, et cetera. And these resolvers also have a variety of privacy and security policies that you can go read. And some of them collect more data, some collect less, and some are sort of transparent in the sense that they don't filter the traffic, and some do filter the traffic. In fact, that's an advertising value proposition for some of these resolvers, that you would connect to them and they would filter your traffic and thus avoid you having to see things, connect to data that is malicious. I won't go through any of this either, really. There's an enormously long history of attacks on DNS at every possible stage of the chain. Once again, we only care right now for the purposes of exercise about the stuff in the red circle. But even that is pretty bad, so it's worth dealing with. And I mean, just generally, there's tampering, there's surveillance, there's a whole pile of things that happen between the stub and the recursive, and then at the recursive. And so convincing yourself the recursive is not malicious and that you're connecting the right recursive is actually super important. I should mention there's also, the scare quotes here, this is probably the only slide that may freak people out too much. There's, as Paul talked about earlier, there's an enormous number of reasons why managed networks do DNS modification. It's a control point which is there, and traditionally if you're in the middle, it's very easy to do. This is done by enterprises. It's done by ISPs, both for surveillance purposes, network management purposes, and also deliver services that the users may have opted into. So a number of ISPs offer parental control services. So you say, look, I don't want my children watching adult content, so I want you to filter adult content out of my DNS queries. And that's a common service. There's also things which networks impose sort of unilaterally that either perhaps because government's required or merely because they've decided that they want to monetize your traffic. As Paul alluded to earlier, all of these to the client are technically indistinguishable. Namely, they all look like attacks. What the client knows is the client wanted to go somewhere, and now you're not getting there. And so distinguishing these is extremely difficult from a technical perspective, and I'll have a bit more about that later. But that's one of the main challenges in trying to do any kind of secure channel DNS rollout. So our approach has two main pillars, I guess you would say. We think of this as a policy-first approach rather than a technology-first approach. So we have selected a set of what we call trusted recursive resolvers. These are organizations which we have a relationship with, which we sign a contract with. We vetted their policies, and they have a minimum security and privacy policy that's guaranteed by contract. And we have, and you can find on our site, you can find the minimum requirements we insist on, and then we insist that they publish their own policies, so you can verify for yourself that they match up to those policies. But we, of course, ensure that those policies match up. Once we have decided to connect to one of the resolvers, we then use DNS over HTTPS to connect to them, and so typical, TLS web PKI verification, there's the right person. And so obviously, what does this do? It guarantees you're talking to the right recursive when the recursive is identified by DNS name, which is what we knew in the first place, thus protecting you against attackers in your network and securing the data transmission between you and the recursive. So this is all like very straightforward stuff. So people often ask why we did it this way as opposed to other ways from a technical perspective. So the first question we often get is like, why not do DNS over TLS? As I'm sure people here know, the IETF standardized these two protocols, DNS over TLS and DOE. Frankly, either of these could have worked. We chose DNS over HTTPS for a sort of combination of prosaic and technical reasons. First of all, like Firefox, as you may have heard, is a web browser. So we do like a lot of HTTP already. Our HTTP stack is very mature, something we understand well. So doing HTTP queries is something that was like very, very convenient for us. There are some potential technical benefits as well. In particular, the HTTP offers the opportunity to potentially multiplex application traffic and DNS traffic over the same connection. This is relevant because one of our recursive, one of our TRRs is a CDN, and CDNs are a natural TRR partner for this reason. You can do things like server push, where you can imagine, proactively the server giving the client DNS data it's going to want. And finally, this fosters an easy transition to quick. So unlike ordinary TLS, HTTP has this thing called alt service, where the server can say, hey, listen, I know you're connecting to me over, in this case, HTTPS with TLS, but you could actually connect to me with quick. And then you have a nice upgrade path to quick, which obviously has some nice performance benefits. It's widely observed that DOT is easier to block. That was not a primary motivation, but we don't consider that to be like an advantage. So it's a side benefit of using DOE that's harder to block. We're not attempting to create a situation where it's like easy to turn off DOE. People often ask also, like, where does DNSSEC fit into this picture? From our perspective, these are complementary technologies. The primary purpose of DNSSEC is to guarantee that the records you get are like the right records that haven't been tampered with. And it provides end-to-end guarantee of anti-tampering. Doesn't provide any confidentiality at all. And we're very concerned about confidentiality because we're concerned partly about data gathering on the client to recursor link. Actually, from our perspective, DOE and DOT too, any of these secure channel technologies are an enabling technology for end-to-end DNSSEC. As is probably known, almost no clients, almost no endpoints, stub resolvers actually do DNSSEC validation. So the vast majority of DNSSEC validation that does happen happens to the recursive. Now, obviously better if the clients did it. You get higher security and you wouldn't have to trust the recursive. But unfortunately, due to the current data suggests, which is quite old by the way, that too many middle boxes in the path tamper enough with the DNS traffic that if what you try to do is DNSSEC validation and then hard fail on the client, what you'll find is a very high failure rate, and the consequence will be an unacceptable experience for users. So all the clients have been very reluctant to turn on any kind of end-to-end DNSSEC validation. But if you have DO or DOT or anything to the recursive, you don't have to worry in the middle box anymore, and you can guarantee the recursive doesn't tamper, as a matter of course. And because the concern isn't malicious tampering, right? The concern is like, hey, I just strip out records I don't know, for instance. And so we're trying to avoid false positives, and so DO and DOT are enabling technologies for DNSSEC, not competitors. I had this footnote here. The latest data here is like extremely old. Some work done by Adam Langley looking to see how much you could retrieve text records. So if anybody has new data that suggests that the channel is clearer, we'd be very interested in having it. This is an experiment we've considered running, but it's not really a high priority for us because for obvious reasons, we expect to roll out a secure channel. So what is our plan? Our plan is really simple. We would like to roll out DO by default to as many of our users as possible, period. That is our long-term objective. We intend to allow users to disable DO if they wish. They can also select their own DO resolver out of either our TRR list or by adding their own one, and I'll show you what this looks like earlier. We specifically want to honor enterprise configurations where the enterprises manage the devices and they wish to not have DO or DOT or substitute their own servers. We have some mechanisms for that. We're exploring more mechanisms. We also want to make sure that when users have asked the ISP to give them a service that depends on DNS, they can get that service, either by using the ISP's resolver or by disabling DO. And we've already had a number of good conversations with ISPs about having better, and other providers are having better filtering, better detection and filtering. And finally, we think of this TR program is actually setting a floor for how all DNS data should be managed. And so we really hope that people will adopt policies like ours, whether or not they actually become members of our program, because we think this is a good standard for how the data should be managed. So this is what this looks like. Basically, once the rollout has started in your area, you will get a dialog box that looks like this. Don't get me wrong, I'll show you a bigger dialog box in a second. And basically, so this just shows in the context of the browser. The dialog box basically says, hey, we've turned on DO for you. We think it's good. If you want to turn it off, you click the disable button. There's been a lot of questions about how exactly this dialog works, so let me be clear. This dialog just hangs out here until you disable it. So we really do expect you to actually turn it off. It's not just like a temporary dialog. But this is what we do. You don't have to turn it on. Once you click OK, got it, it's on. And learn more obviously takes you to some web page that tells you more about the thing. We struggled. People often want to discuss this text here. I can discuss it if you want. It's been extensively wordsmithed by our UX people and our lawyers. It's incredibly hard to explain to anybody how this stuff works. This was what we could fit in here that we thought was reasonable. If you think this is misleading in some way, I'm happy to listen. But there's a lot of critical mass around most of this text. And I guess I should say they keep tuning it, so it may have changed a little bit in between when I made these slides. So the actual dialog looks like this. So there's a network preferences box you can find. And then it has this checkbox for enable DNS server HTTPS. That checkbox will obviously be checked in the case we've turned it on for you. Then there's a pull down that allows you to select your provider. And by default, and so you can see which one we think is the default in this case. It's quite likely we'll have different defaults in different geographies. I'll get to that in a second. So what about enterprises? I said we wanted to honor enterprise configurations. Generally, if we can detect there's an enterprise configuration and that configuration didn't turn on DO, we will disable DO ourselves. This has a bunch of checks we run. So Firefox has an enterprise policy setting where enterprise can set a variety of policies for how Firefox will behave. If we see anything there and they don't explicitly turn on DO, we just disable DO. If it explicitly turn on DO, then we'll honor that choice as well. In addition, if you install a new trust anchor, so a trust anchor is a new root certificate, then we also assume that you must have some kind of you must have something going on and we turn off DO. I just wanted to circle back actually to this point, make it really clear, because Paul was mentioning this in his previous talk about sort of what the implications are of DO for enterprises who do man-in-the-middle inspection. The chain of reasoning here is that if you have man-in-the-middle a new trust anchor, we'll turn off DO. which also means we turn off encrypted SNI if we ever turn on encrypted SNI. So basically, if you have your own trust anchor and you have any kind of man-in-the-middle proxy, then you're then you just be the status quo ante, because we're not like trying to get like in a fight where people control the computer. Our recommendation is that network administrators actually like use Firefox policy to configure DoH themselves. We think it'd be great if enterprise administrators like ran DoH for their own servers. It's not like clear, enterprises are big and the networks are big, and there's no particular reason to believe the network is actually secure. So everybody's running encrypted transport, and we suggest that people do that, but we're not going to make them. If we get a failure, a DoH resolution failure, currently we'll fall back to system DNS. This is a compromise between the fact that there's the real world that we're deploying in and the ideal world. Obviously, we prefer to fail closed in that case, or fail, I guess, safe, like we're not going to connect. But there's way too many situations where DoH will be blocked or where there's split horizon that we can't do that. So it's a temporary situation, hopefully. Adam Langley, he's pointing out that like iron law of the internet is like the last person who touches anything gets blamed, and so obviously we can't like roll out Firefox in a setting where a big fraction of people like the resolutions don't work properly. The second configuration that we'd like to honor is parental controls. So we're aware that, as I said, there's a number of situations in which there's opt-in parental controls. We have a bunch of heuristics that we run that attempt to detect when these are happening. One of these is not universal, namely this OS level parental controls. We're like sort of fighting with the operating systems to like make sure it works. But in general, we'd like to detect the operating system controls. We also check for like these safe search URLs. So I don't want to go into too much detail, but there's a bunch of mechanisms you can use to convince Google to only serve everybody in your network non-adult content. And if we detect that, then we'll also disable DoH. And finally, what we do is we do these query resolutions for canary domains. So a number of providers of parental controls will have a domain which is an innocuously named domain that also they block, that they control. And the idea is to allow you to test that current controls are on without having to go to an adult content domain. And so we check for those. We also have our own domain, which we recommend people use to make it easier. And we've done a bunch of engagement with people on that. This, like the previous slide, is an awkward compromise in the sense that it allowed an active attacker to disable DoH for all their users. We're not like super thrilled about that. We do monitor for abuse of the canary domain, and if we see a network that's abusing it, then we're going to have to take some action. As I said, it's kind of a pain in the ass for us to collect all the canary domains everybody uses, and it also is difficult because then they can't change them. We have a canary domain that we have registered, and we've been working with parental control providers to get them to use that themselves. And there seems to be a fair amount of uptake of that. I was hoping to have some data to show, but it turns out I don't. But what's harder because we're measuring it, and there's a fair amount of uptake of this domain. And again, we're monitoring this situation. Okay, well, this is just, I don't know what is my slide. This is just pitching. I guess one thing I do want to say, though, is like we are currently working on getting more TR providers, and in particular, we do know that people use resolvers for filtering, and we're interested in talking to providers as non-default to do filtering, so users can select it themselves. By default, we require no filtering, but that doesn't mean we don't think that users shouldn't be able to select for filtering themselves. I don't want to talk too much about our policy, but a little bit I want to talk about it. So really, we focus on two things. We focus on minimizing user data retention and minimizing user data disclosure. We require a maximum of data storage lifetime of 24 hours. We require a bunch of privacy notices, and we also require that you not intermingle the data in various ways and not use it for any purpose essentially other than providing the service. We also basically currently forbid essentially any kind of blocking at all. Essentially, other than like that mandated by government. This has been a topic of a number of controversy, and it's something we're sort of exploring right now. In general, probably the thing that is most controversial is the requirement that the block list be published. So that's a real point of tension for a number of kinds of blocking. So this is something we're sort of working through. But the general concern that we have here is we know there's been a lot of DNS level blocking that is unaccountable and overblocks, and so we want to ensure that whatever mechanism people use for determining block lists is transparent enough that users can be persuaded that there's not overblocking. I originally wrote this slide last year, but we're going to be putting our policies out for public comment sometime earlier this year, and this is something we committed to in public. Okay, so before we did this, like we've been working on this for a long time, and rolling it out has taken longer than like anybody on our side hoped. We ran like an enormous number of experiments to try to convince ourselves that we weren't going to be doing any damage. We probably ran about 6 or 7 experiment sets measuring like performance of the resolver itself, performance of the page load, measurement under organic conditions, measurement under like forced AV conditions. There was some concern at EDNS client subnet, so we did some work with both Akamai and Facebook to measure that. And we also did a bunch of work to measure how often like these heuristics to like disable DOE triggered. The general story is pretty good. The general story is the performance is roughly comparable, and I'll show a slide in a second, between DOE 53 and DOE. And so we consider this to be an acceptable experience and one we're prepared to roll out to our users. This slide is somewhat interesting. There's been a lot of work actually after this on DOE 53 versus DOE performance, especially by Feimster and et al. So what our data shows, and this is with Cloudflare, but our data shows basically that up to like the 80th percentile, DOE is like fractionally slower, like a few milliseconds slower than DOE 53, but then above like the 80th percentile, actually the situation is much, much better because a lot of people have like terrible resolvers and the connection to Cloudflare is extremely consistent. There's also some evidence that suggests that in bad network conditions, TCP actually overperforms, even with TLS, overperforms UDP because of the retransmission is better. So again, there's been a lot of work on this. We sort of fixed endpoints by like by Feimster and others. This data is gathered from actual user clients, so it's sort of like it's noisier, but it represents a broader cross section, so it's a complement. Anyway, this data shows approximately what everyone finds, which is like there's no substantial performance impact, negative impact from DOE. This is my last slide, but I made you wait the whole way so you can see what we're going to do. Short story is we're starting the rollout this month. We will only be rolling out in the United States initially. Once that is complete, we'll start looking to do rollouts other places, but our initial plans only cover the United States. And we'll do public communication before we do the rollouts. We're starting with two 2R partners, Cloudflare and NextDNS, and Cloudflare will be the default for this rollout. So the user will be a select NextDNS, but it won't select by default. We're currently sort of the last stage of a 1% deployment rollout. So the way we do these rollouts is we start small with a relatively small fraction, and we gradually dial up the number of users to look to see how many people are experiencing problems and look for bug reports and that kind of stuff. So we did this 2% A/B test and measured a bunch of stuff. Opt-out rates, error rates, what we call retention rate, which is do people like stop using Firefox because like that's generally a sign they're pretty annoyed at us. All those numbers look good. And then just due to like, holidays and some stuff, we weren't really ready to roll out until Firefox 73, which comes out next week. We'll be doing first turning it on for like US nightly and beta users without a throttle early next week. Because those are relatively small populations, they've already opted in to like some level of like instableness. And then we're going to start on 218 is the current plan to start a 5% jump, and then it'll bake for a week or two, and then we'll gradually dial it up, with the target basically being all US users relatively soon. Questions?
Akamai. So the one thing that I've found during my testing is kind of like you per default use /00 ECS when you send queries to any resolver or to any DOE resolver. So if I configure my my custom DOE resolver, I'm not getting ECS. Are there any plans to expose that in the UI?
I'm going to need you to repeat that. I'm sorry.
So you're sending the 00 signal, which means don't do ECS to the recursive resolver. While, Cloudflare doesn't support it and others may not, there are resolvers out there that support it. So would you consider either having an UI for that or switching it sort of or don't do this 0-0 signal if you are configuring a customer resolver?
Yeah, I don't know. I think we did see how much demand there really was for it. Every UI element is like cognitive load in our users, so I think if there was evidence a lot of users would know what to do with this, we'd be interested in setting it. But if users don't know what to do with it, it's pretty hard to set anything. I'm sorry, it's a little unsatisfactory, but it's just like, like every time we expose some technical detail to users, they're like, what the heck is this? So I think we need to see some evidence that would be widely used.
Okay, thanks.
Hi, Evan, two things. You asked if anybody had new information about the clarity of the DNS-OARC channel. A lot of the problems with false validation failures was due to EDNS noncompliance, and we just had a big flag day a year ago that has, according to what measurements we have, has greatly increased compliance in servers across the board. It's not the only problem, but one of the big problems has been eliminated and largely eliminated, and probably it's going to be less of a problem now. The other question was, it wasn't clear to me, there's a couple of ways of locally disabling this, a canary domain, a trust anchor. What's your plan when every hotel and coffee shop starts doing those things?
Right, so let me start with our aspirational goal, which is that you should have to control the computer in order to disable this. That is our aspirational goal, and so coffee shops could, of course, ask you to install a trust anchor, but they don't do it now, and I think users will tell them no. We're more concerned about the hotels and coffee shops sending these uncontrolled network signals that disable DOE, so that canary or blocking DOE. As I said, we're monitoring that situation. If it starts happening a lot, we'll have to, so we would like to eventually turn off these insecure signals. And one thing that would cause us to turn them off faster would be if there's a lot of abuse.
John Reed, Akamai. Two questions. One, you said that when end users have opted in to parental controls, that for a trusted resolver, that's okay with explicit consent. How would a user indicate to the resolver who they are and that they have opted in?
Okay. I actually don't know precisely how people who provide this now do it. I imagine either, there's been some discussion, I think, on the Eddie list about this. My assumption is either they take the entire customer and whatever machine behind the NAT, they just assume they block them all, or somehow they expect to get other information they use for this. But our expectation is that whatever technique they use to differentiate the users now, they ought to be able to use a TCP. If that turns TLS, if that turns out not to be true, then sorry, it's been a long day. The way we detect for for the parental control setting is by doing ordinary DNS resolution, and so the point being that that should fate share with it blocking itself.
Okay. Then following up on that, similar to Ralph's question, if you want organizations, enterprises, things like that do control the computer to adopt DOE, they're going to want a way to identify their users, particularly in a roaming environment, and that can be through EDNS client subnet, through client MAC, things like that, all things that so far Mozilla has said we're not going to send because they are a privacy violation. It doesn't matter who owns the DOE and who owns the computer. So I'd like to reconcile those two things of encouraging enterprises and organizations to adopt DOE while saying we're not going to send you any of the information you need to do that.
Sure. Well, so I guess we haven't come to a position on whether or not we're going to have some enterprise configuration that let you turn those features on. Honestly, this is the first time I heard this suggested, so I haven't really thought it through. The policies that we are setting are designed to be the policies, the default policies that consumers get when they use Firefox. In general, you can do all sorts of if you control the computer and you can configure Firefox with the enterprise settings, you do all kinds of terrible, awful things that no sane person would want to do. Not just ones not just things that that the enterprises want to do that someone might not like, but things that no sane person should do. I think if there was a lot of if we could get a clear statement of what the use case was, we could at least have a conversation about what it'd be like to expose that in those enterprise settings.
Okay, I'd be happy to talk more about that because enterprises are knocking down our door asking for that. So.
Yeah, no, we'd be happy to have that conversation.
Hi there, Fred Baker. Does Firefox verify DNS-OARC signatures?
No.
So I have a bit of a conundrum. I don't have a problem with confidentiality of the tunnel. That's great. But I'm being told by at least some of the resolver operators, and I'm thinking specifically of Google, that they don't see a need that they have to verify DNS-SEC signatures because, of course, the end system is going to do that. If you're not doing that, then it's not being checked. And I'm sure you've talked with Steve Kent, and he's told you about channel security and content security. I'd like to see them both done because I'd like to know that the data that arrives at the end station actually is the data that was intended by the guy that was sending it, which is IANA or whoever. What do we need to do to get to the point where DNS-SEC is actually validated in the browser?
Right, yeah. Well, as I say, I think that from our perspective, I think that is going to post-date the DO rollout because build it. First of all, let me say we don't have our own stub resolver at all. Namely, this is going to get technical real fast, but like Chrome has their own stub resolver that talks UDP. If we disable DO, we use the system resolver, and so doing DNS-SEC validation for us with DO53 would be basically like a lot of work because you have to like actually write a resolver first. We're certainly open to adding DNS-SEC validation to the to Firefox when DO is in use. It's just not the top priority. I guess it's a matter of like we think getting this done is more important.
When the TLD users start doing it right now, Dan, remind me, we have 1,530 names in the root, and they're all signed, aren't they?
Not all of them, but most of the CCC users, 95%.
95%.
Sure. I think the value question for us would be what fraction of leaf domains are signed, because that actually is what that actually tells us all the way down to the A records. Because until you have that, it actually isn't adding very much value for us. In any case, I mean this isn't something we're opposed to doing. It's just not the top of our priority list.
This is Ulrich from .se. For .se, the answer is 50% of the zone is signed down to the A records. So
Sure.
Yeah.
I know you had incentives.
Yep. So what I would ask the policy for the trusted resolver, I didn't hear you say it requires DNS-SEC validation.
It does not.
Reasons?
We didn't fundamentally think that was the most important thing to require.
Sorry?
We didn't fundamentally think that was the most important thing to require.
That answers are correct is not important for a trusted resolver.
I guess we're getting to the point where our judgments of how important DNS-SEC is as a security measure are not correspondent. We think it's a reasonable security measure, but not one of extraordinary high value.
Okay.
I'm not saying it has no value. I'm saying we think it's corresponding to lower value than what we're doing.
Hi, this is Dina from Cloudflare. From your deployment so far, what has been the opt-out rate?
I'm sorry, I don't know. Pretty low, but I don't know.
Okay, good. Thank you.
Brian Dixon, GoDaddy. Question about the opt-in to other resolvers. If other resolvers are operating DOT but not DOH, you don't support opt-in with DOT?
We don't support DOT.
Because I can understand not doing that as your default, but I'm surprised that you wouldn't offer that as an optional.
We haven't implemented it.
Wes Hardiker, ISI. So I guess a couple of really quick things. First off, Victor Duchovny measures the number of signed A records all the way to the end, and it's updated nightly at stats.dnssec-tools.org. Highly useful to look at if you want. So one real quick question about your slides. Are you doing those detections of whether you're behind a child protecting type of service or something like that on every network change? So you're actually...
I'm sorry, I'm trying to remember what we do.
That's fair.
I think the answer is no. I think we do it in first install, but I'm not sure.
Okay.
That's certainly when we decide where you are.
In the past, Mozilla's position has been, with respect to DNSSEC, that it's not important because the HTTPS already kind of solved it, and PKIX was more important. It sounds like that is that shifting a little bit.
I think let me try to I'm not writing, so this is going to come out a little more informally. I guess my position is the primary defense that users have against impersonation of the remote endpoint is WebPKI. It is not control of the network, and the reason for that is because in many cases you have on-path attackers between the user and the remote network, and therefore having the correct A record does not solve the problem. And so fundamentally we should be working to harden the WebPKI. With that said, I think DNSSEC does have some value, and it's something we prepared to look at offering. It's just not like at the top of our list.
Understood. When you do get to it, there's an 8-year-old patch in your Bugzilla tracker that we submitted to you 8 years ago that implements the resolver in doing DNS support in Firefox. It's still marked as open, so you can go look at that as a start.
Thank you.
Ralf from Akamai. Sorry, I forgot my question. Second question.
I'll wait.
So you are, of course, with switching traffic to Cloudflare, centralizing a lot of the user's traffic, and that in general I would consider not a good privacy thing. So going forward, if the IETF came up with a method to identify the resolver, that is the resolver of your, say, ISP's network or something, that would have had this qualities that you want, would you then consider an auto upgrade or switching back from the Cloudflare resolver?
Well, so first let me challenge the claim you just made. So at least in the United States, the ISP market is incredibly centralized, and so I believe 5 ISPs.
There's still more than one Cloudflare or 2.
Can I finish? At least in the United States, the ISP market is incredibly centralized. I believe 5 operators control over 80% of the market. Firefox is a relatively small market share, and so converting from your captive ISP to Cloudflare, I think actually probably improves diversity rather than making it worse. With that said, we are the hypo you're phrasing is a little complicated. We're certainly not prepared. Well, certainly merely accepting the network's word that it has a preferred resolver obviously doesn't solve a problem because it doesn't guarantee policy compliance. We would, however, be interested in exploring having networks indicate that they are part of the TRR program and that they would prefer. So ISP X says, I'm ISP X, and then we go, and then I would like to use my resolver, and we go and look and verify it's in the TRR program. That's something at least we'd be willing to look at doing steering under those circumstances.
But if the IETF came up with a mechanism sort of to do that, then you would implement that and follow that?
I guess we have to see what the mechanism was. We're interested in seeing the IETF develop such a mechanism. More concretely, to the extent to which ISPs are interested in doing that now in advance of a mechanism, we'd be interested in experimenting with it.
All right, thanks.
Thank you for the questions. Thank you, Eric. Okay, so we are running over time, so just a few things. The lunch is served in the atrium at the lobby level, so I was told you just leave out of this room, turn right, then turn left, and go 1 level upstairs. This room will be locked after we all leave, and it will unlock 30 minutes before the next session. The next session starts at 2 p.m. If you have submitted Lightning Talk, please watch your inbox whether we have accepted or rejected. If you wanted to submit something and didn't manage to, please come to us just after I finish here. And that's it. We would like to thank Comcast, which sponsored this event, and we also would like to thank VeriSign, who is our annual sponsor for the workshops in 2020. See you soon.